stick
like
is knowledge.
Who would do both.
Maybe you can get a yardstick.
His big stick is knowledge, guys.
Okay, here we go. Look up. Okay, new word today. Yes, pair of words. Differential equation. So you'll start seeing problems now where they'll say, consider the differential equation, given the differential equation. Okay, the word differential equation need not bother you. It simply refers to an equation that contains a derivative. So I think the best way is, again, go back to Danica's chart. With Danica's chart, you have a column here, F, and this column, F prime. But sometimes we use the notation, this is y equals something, and so this is dy dx, like that. So when they say consider the differential equation, all you have to think is, oh, they're giving me this formula. Okay, that's all they're doing. That's all they mean when they say consider the differential equation. They're just giving you this formula. Question? So points for the whole room. So what will we typically use this formula for? We've had it all year long now. What do we use it for? Hands, please. Hands. This one here. What is its use? Most common use of that formula in AP calculus problems. You've used it a lot all year. What do you use it for? Come on. Talk to somebody who has their hand raised and get your hand raised. Sitting passively doesn't help at all. Like, you have to listen actively. What's the formula for it? Look, when your hand's not raised, find somebody whose hand is raised and then raise your hand. Like, find out. Nicole, what's the score?
Let's go.
Say again. It would definitely find xy coordinates on the graph of f prime, for sure. 2 points. We actually use it more often for something else.
Would it be to find the slopes for f(x)?
Cool. We use this formula to find the slopes of f at different points. Show me your hands if you knew that. 2 points, 3 for sure.
So if you said to find points on a graph, is that too vague to be?
No, you get 2 points for that. It is finding points on a graph. You want to be more specific and indicate that it would find points on the graph of f prime, but nothing wrong with that. Okay. So again, look, when it says consider the differential equation, you're not going to freak out. You're just going to say, Danica's chart, they just give me this. A way to find the slopes of this. That's all they're doing. Questions? Okay. Then it says, find the particular solution. Now remember, y means same as. So they're saying, find the particular solution y, or if you like, call it f of x, either one, to the given differential equation. They are saying, we gave you this equation. Would you please find this equation? That's all they're asking. Are you with me? Okay. Now, if they had said something like this, it's really very easy. You would simply say, oh, then y must equal x cubed. Like, it's not hard. If this is the derivative of something, then this is the function itself. What makes this more difficult is this formula for dy dx contains both an x and a y. So it's not as easy as just kind of look at it and write down the answer. But that's all we're doing. They're giving you this, you're trying to find this. Question? So don't let the wording bother you, please.
So basically, if the question is said, find the antiderivative equation of this, would that be the same?
Essentially the same thing. There are some technicalities why that's not exactly right, but good enough for our class. It really is. 2 points. Okay. Because this equation contains both an x and a y, we have to have a formal procedure for finding this equation. Okay? Now, to help you remember the steps to this process, we're going to use this little acronym, I don't know how you want to pronounce it. I call it the Sassy Method. Sounds edgy. So, hope that's the right word. Sassy Method, is that okay?
Yeah,
Probably
that
should
sounded great.
call it the Sassy Method.
The Saki Method? Saki. That, never mind. Okay, here we go. Write this down, please. dy dx equals.
Oh wait, never mind. I'm thinking of such.
I don't like having a negative kind of in the middle, so I apply it to the top. I think it's easier. It can go to the top, the bottom, or just stay in the middle, but put it somewhere. I didn't understand.
Like, instead of just having it in the middle, like applying it to something.
I just think it's easier. Yeah. You good? Okay. The S stands for separate. Separate the variables. Look at the dy dx. For our class, dy dx always represents change in output divided by change in input. So the output variable is y, the input variable is x. To separate means put the output variable on the left, input variable on the right. It really doesn't matter, but that's how we're accustomed, so that's what we'll do. So the first step is always the same. Multiply both sides by dx. That step never changes, it's always the same. Now I'm going to multiply both sides by y. And now I have successfully separated the variables. This is on the written section. I've just earned 1 point for doing that. Did I talk about how many points you have to earn to get a 4 on the test?
60.
60.
Out of 108.
Out of 108. So this is a pretty easy point. Yeah. Question?
So output on the left. instead of-
Yeah, just because we're used to writing the equations y equals. You could do it backwards, it wouldn't matter, but it's easier to do it this way. Okay, next step. The A is what Jacob was talking about. It stands for anti-differentiate. So you apply the antiderivative operator to both sides, like so. Now you just find the antiderivative, so this is y squared over 2. We don't want everyone to think that C is the most important letter in the alphabet. Oh, please.
So, this might be kind of a dumb question, but what are we doing right now?
What we're doing,
The,
keep talking, I didn't mean to cut you off, sorry.
just what's the overall, like we're not anti-differentiating to find the answer. We're going through this Sassy method. What's that doing?
Gotcha. No, it's a really good question. So are you comfortable that what they gave us was an equation that belongs here in Danica's chart?
Yeah.
And what they're asking us to do is to find this equation.
Yeah.
So going this direction, general thing is what Jacob said, antiderivative.
Yeah.
But because of the fact that our formula has x and y, it's just a bit more complicated.
Okay.
That's all. But the big picture is we're trying to go like this and find this formula.
We just use this way because this has the x and y.
Because of the x and the y.
Okay, makes sense.
Because of the x and the y. Without the x and the y, it's a lot easier. But with x and y, we have to use this method.
Okay.
Good question. 3 points. So I'm kind of prejudicial because C is the first letter of my name, but we don't have to use C. We can use whatever. So D. Dan. Okay. Danica. Equals negative 2x squared over 2. And Ethan looks good, so E.
There we go.
Do
Okay.
you have to put different letters there because they might be different numbers?
That's kind of the idea. But in reality, Bree, question.
Oh, was my
2
question.
points for you and Jackie. But notice, whatever number this is and whatever number this is, they're just constants. So we can add them together. Like we can move this over and say E minus D,
And then they'll be 0.
and then just call it a new what'd you say?
One day, like, if it was plus C and plus C, wouldn't you minus the C over and get 0 on one side?
The trouble is, you don't know that they're necessarily the same because they came from different antiderivatives. But if we put it over here and it becomes E minus D, then we can call it C again, actually, or F, or whatever. It's traditional to use C, and since it is the first letter of my name, we'll stick with that. Okay. A little vanity there. Okay, most important thing, actually, is you don't have to write D and E. Like, don't even write this line. Just go to here. The grader doesn't care. Just put plus C. It's good enough. Another way to think of it is look over here. It's back to Ethan's question. The whole goal is to get an equation for y equal. And the very last term in that equation could be plus 10 or plus 0. You don't know. So we just need one C. We don't need two. So, question. Awesome. You've done the first two steps. You have separated, you have anti-differentiated. If you look in the back, it'll show how points are awarded. So go to 14.
Is that the answer?
No, we're not finished. But we've done this so far. We've separated the variables and we've found the antiderivatives. So we have earned 2 points. So next step is the C. I wanted the little memory aid to kind of rhyme. So C is separate.
What?
A is...
Wait, S is separate?
Ah, shoot. S is separate. A is, well, Smith, you know. S is separate. A is anti-differentiate. I had to make up a word for this one. Constantate. Constantate. If you look in the dictionary, it will say verb to find the constant.
How do you spell that?
How it sounds. Constantate. Constantate. The verb to find a constant.
The last one.
That's differentiate.
No, good guess.
Initiate?
No.
The end in A.
Yes, it ends in 8.
Infinite.
Okay, look. Can I erase this? Is everybody clear that we are starting here, we're trying to get here? Are we good?
Yes.
Let's erase this. Okay, constantate, find the constant. So this step is really easy. They tell you right here, we're looking for the formula for F. Well, this says that when the x-coordinate is 1, the y-coordinate is -1. You have an equation here with x-coordinates and y-coordinates. When the x-coordinate is 1, the y-coordinate is -1. Just plug it in. I thought of making it sappy, like plug in 8, but constantate rolls off the tongue more easily. So plus sappy doesn't sound like a good. Sassy sounds more cool, edgy. You know.
Yes.
Never mind. Okay.
Sassy.
So I put, let's see, the y value is -1. Make sure you put parentheses when you replace the variable. Don't forget the negative is really -1 multiplied by, like that. Question? Don't lose track of the big picture. All we're trying to do is find y equals something. So 1/2 equals -1 plus c. So what is c equal to? 3/2. Shoot.
That's not right. Oh my gosh. Wow. Sexy. Well, he worked upon me with this, Duncan.
That's funny.
It's like,
So Jackie's comment reminded me of, this was like 13 years ago. I had student teachers once. I've never had them again.
I would. I would transfer to a period where you need to listen to does it.
So we were in a meeting after school with the student teachers and their supervisor from BYU. And the supervisor was trying to give the student teachers little tips that he'd observed as he watched them teach. And at one point, they got really frustrated. They said, well, they're like, the problem is, like they pointed at me like very accusatory. Like, he treats them like they're his coworkers. They're like, what's wrong with that? But they were like kind of upset about it. Never mind. Okay.
Wait, the advisors were upset or the student teachers?
The student teachers were upset with that. So. I think that's a good way to do this. Treat each other on an equal level, you know. Is that not? I hope it works. So. I hope you feel that way.
So, should we always imagine like the negative in front of an x is just like a -1 times the x?
Yeah, it is for sure.
Okay.
Yeah, think of it this way, Tyler. 2 points. If I write -2 times x squared, no one ever thinks the -2 is the x. It's -2 times. Negative means -1 times.
Okay.
Yeah, it always has. It never means -x. Good question. There you go. Good.
If it wasn't x and y, what would you separate?
Oh, the problems will vary. Like, for example, you'll see one in a future AP test that looks like this. Sorry, get the thing to work. Thank you. It looks like this. What's the output variable? Say it. What's the output variable?
W.
W. It's always change in output divided by change in input. So what's the input variable? T. So you're going to separate W and T, the goal being to get W equal. Is that your question? Yeah, it's really, look, it's always easy. Just look at the derivative they're giving you. Top is the output, bottom is the input. Separate. Good question, 3 points. Okay, we've earned 4 of the 6. No, 5. Was 5 points possible on 14? Help me.
I got my confused.
5, thank you. We have earned 4 of the 5 points. Because if you look in the back, one of the points is for finding C. Another point is for using the initial condition. We have used the initial condition. We have found C. We have now earned 4 of the 5 possible points.
So this is solve for y.
Now you solve for y.
What exactly was the
I don't. Okay, the word initial condition is confusing. So don't try to associate meaning with the word. It's simply an xy pair that they're giving you. So you have this equation with x and y. Initial condition is going to be an xy pair that they give you. So they gave us an xy pair. They said when x is 1, y is -1.
How do we solve for y if we already know y is -1?
No.
Wait, are we plugging? You should show us how to do it and it'll make sense.
True. Here we go. So we know the value of C. So look, I'm going to go back to this blue equation.
Oh, you have to get rid of like the y squared and just have it be y?
Correct.
Oh.
The thing to remember is, it'll make more sense when we finish. You're right.
Yeah, I probably should have just waited for you before I asked that.
No, you're fine. Questions to that? Plug in C. The last I. What's the last I stand for?
Initial.
Has to rhyme with 8.
Initial rate.
Initiate.
It's a real word. What are we trying to do at this point?
Discover it.
What's the goal? Get y alone.
Isolate.
Isolate.
Hey.
3 points. So I multiply both sides by 2.
It's like 7 different ways.
So I multiply both sides by 2. You get this? Don't forget the 2 must distribute. 2 must distribute. Question? Pretty good?
And then you take the square root.
Square root. Now, when you are solving an equation and you square root both sides, you get 2 possible answers.
You get the negative with the positive fraction.
Yep. So now you got to figure out which one is correct.
Plus or minus square root of the negative.
So that's one possibility. The other possibility is right here.
Can you just do the plus or minus?
You can. There's a reason I write both, but you can do plus or minus.
Then how do you know? You figure out which one will end up being negative 1 if you put in 1. Got it.
We have an equation, y equal. But the equation has to work in such a way that when I plug in x equal 1, I get a y value of negative 1. I don't have to do any work, I can just look at it.
It's the bottom.
It's got to be the bottom because I got to get a negative. So done. So I make sure the grader knows which one is correct. Cross that out. The answer is not plus or minus,
Can
it's
you
one or
write
the
that
other.
to like help
Yeah, and then on the
yourself
next line you
remember
just,
the next line be
for
like,
sure.
This one.
Yeah, you could have done something like this and then said this is the answer. That's fine.
Do you know the negative 1 was right?
So the big picture again is, remember this. We started out realizing that we've got a Danica's chart here. And they're giving us, oops, not two, sorry. They're giving us this, also known as dy dx. So they gave us this equation, like that. And we're trying to find this equation.
But don't both the plus, the positive and negative equations equal y?
True. However, there are two conditions. Stay with me, this is really good. One condition is we've got to make sure we can do this. We can go from this column to this column. And this works for that, the plus or the minus. But we must also find an equation where if you plug in a 1 for x, you get a negative 1 for y. And let me erase this. The positive version of this doesn't work. Like, stay with me, I'll help. So we plug in a 1. So what's 1 squared?
1.
Times negative 2 is?
Negative 2.
Plus 3 is?
1.
Good. What's the square root of 1? 1. So this equation gives the wrong answer.
Oh, so it's negative 1.
Right, it's supposed to be negative 1. This one works. Does that make sense? Perfect. 3 points.
Can you get us the negative from the square root?
The root itself, it's a matter of interpretation. It really is. It looks like
Square root of a negative number?
you can't do that. Not without complex values, which we don't study in this class. Is that your question? Yeah. Okay.
What's a complex value?
Imaginary numbers.
Imaginary numbers.
Oh.
Yeah.
So really funny concept. Like
If you want to find a real life application of where they have used imaginary numbers in something that is real, study electrical engineering. Circuit theory is completely based on the application of imaginary numbers.
imaginary science.
No, the word is wrong. Like whoever discovered the idea, they discovered it before they knew a use for it. Imaginary is the wrong word. It's
I
like,
just find it funny to say it like that.
I agree. Like, think of it this way. Originally, when people talk about negative numbers, half the population probably thought, that's stupid, that makes no sense, a negative
You
number.
can't have anything below 0.
But as soon as you apply an application, oh no, it's easy. It just means like you're in debt instead of having money, right? It's just a different way of keeping track of things. So I don't like the word imaginary. That's why I say complex. So anyway, I'm rambling. We good?
Yeah.
We good? We found the equation. This is y prime. Question? That's it.